Okay, we are starting chapter 4. So we're going to, it's the number theory. It's what 6th grade's doing right now. And 4.1 is prime and composite numbers.
So we're doing the same thing as 6th grade?
Well, yeah, y'all did this last year. And each year you're taught like the same basic concepts, is just taking it up a notch. So what you're doing this year is going to be a little bit harder. Okay. Let me see something real quick.
What happens if I had a question?
Skip it, and then you can ask me.
I totally forgot she was there.
You can if you have a question, you can ask. Okay. Like seriously, you can ask. You can come over here and ask. Okay, so we're going to discuss, well, prime and composite, but the first thing we need to talk about, because I'm pretty sure you know what prime and composite is. What are prime numbers?
Numbers that have like multiple numbers that go into them.
Prime numbers are numbers that,
Or even.
nope. Ooh.
So aren't they numbers that like 6 would be a prime number?
Let's start with that. Prime number. I'm going to redo my notes. Usually we don't start with this, but we're going to.
Is it where it has like a number of times itself that can make it?
A natural number greater than 1 that has,
What does it mean by natural?
like a normal number, whole number, has the 2 factors, bless you, of 1 and that number. So usually I teach y'all about factors first, but we'll start with
I
this.
don't understand.
Well, just write it down. I'm going to explain it to you. A natural number greater than 1 that has the 2 factors of 1 and that number.
I think we forget these things because we're focusing on we learned so much other stuff in the
Yeah.
year. And then
But see, I usually start teaching y'all about factors, but I'll start with this and then we'll go back to what factors are. For example, this will bring it home, Tanner, right here. 13 is prime because the factors
are 1 and 13.
are
Okay, yeah.
1 and 13 only.
That could be any number.
No. Well, no. Is 4 prime, Tanner? Can only 1 and 4 go into 4? Or is there another number that can go into 4?
2.
Exactly, so then it's 4 prime. No, because prime numbers only have 1 in itself as a factor.
I remember that. I don't remember.
For example, 5 is prime. What numbers can go into 5, Tanner?
1 and 5. So pretty much odd numbers. I put 1 plus 1.
Not always. Not always. Because, Tanner, think of the number 27. What numbers can go into 27?
8 and 3 or
Close. But 3 can go in there, right? 9 times. Okay, so then it's not prime, right? So certain numbers are prime. 11 is prime. Because only 1 and 11 can go into it. Now, the other end is composite. numbers. It's a natural number greater than 1 that has more factors than 1 and that number. Composite numbers. They're natural numbers greater than 1 that has more factors than 1 and that number. For example, 16 is composite because its factors are Joseph, what numbers can go into 16?
1, 2, 4, 8, and 16. Ms. Rogers?
Yes.
How do you know which ones are how do you figure out which ones are composite and which ones are?
You have to know divisions, your division skills. You have to know divisibility. You have to know. All you need to do, Tanner, is if you can think of just one number, one other number, like, okay, so 16, we know 1 and 16 can go into it, right? Okay. If you can think of just one other number that can go into it, it's composite.
Oh.
You see what I'm saying? I mean, it's composite. There are some numbers that are easy, like 5, 11. You know what I'm saying? But when it gets a little bit bigger, it's a little bit harder. And there's some numbers that are a little bit bigger that are prime that man throw my students off.
Well, aren't all even numbers composite?
Okay, all even numbers except for,
But 2,
by definition,
besides 0.
2 is prime. It's the only even prime number.
I thought you were going to say that it was 0.
No, by definition, 2 is prime. So, kind of what you're saying, all even numbers are composite.
Except for 2.
Okay. The number 1 is neither prime or composite. It's just neither. So those are the two weirdos. Those are the two weirdos. 2, it's even, but it's prime because its factors are 1 and 2. Okay? 1, it's 1 and 1. It's neither. It's not prime, it's not composite. Does that make sense? Okay?
But wouldn't it be prime because 1 can go into 1?
Well, if anything, yes, except for the fact that by definition, prime is that has 1 and that number has 2 factors. So 1's factors are just 1. You know what I'm saying?
1 to the 0th power.
Yeah, but still, it's natural number. So by definition, 1 is neither prime or composite. 2 is prime because its factors are 1 and 2.
Either way.
And this is just 1. Okay? All right. Now, let me go back to the beginning. Now we're going to talk about multiples and factors. Now that we understand prime and composite. A multiple. Now, what does that word even sound like?
Multiply. Just multiple. There's multiple of them.
Okay, or multiply. So I'm writing multiply underneath. Multiple is the product. What does product mean?
Like answer to a division problem, I think.
Answer to a
Multiplication problem.
multiplication problem. I'm going to put a little dot there. The product of an integer and any natural number. Multiple, the product of an integer and any natural number. The product of an integer and any natural number. Joseph, you got it, buddy? Okay. And I'm going to give you examples in just a minute. Factor. Is the opposite. This deals with like division. This is any integer that divides the given integer with no remainder.
Is it an S or a G?
Here, give it. It's a G. My handwriting's terrible. I hear y'all been telling Coach Cole that. He said that my grades, y'all make fun of how I write my grades.
Yeah.
Oh no, I'm fine with that. I laughed. I even showed him examples. I said, "Here you go. Here's one," and he's like, "What is that?" That's 100. Any integer that divides a given integer with no remainder.
Is that 4G? It's like an S.
What is the remainder again?
No remainder. Oh, well, like if you, okay, like 5 divided by 2. Can 2 go into 5 evenly? What's left over is the remainder.
Oh, okay.
1.
2 numbers that are multiplied together to get the multiple.
Anything else that we have to underline?
No.
I'm thinking y'all writing, so I'm still on my first page.
I'm on the second page.
Do you have everything, Tanner?
Yes, ma'am.
Okay, so let me explain what this is. Okay, multiples. Examples of multiples. Let's say multiples of 4. Okay, Talia.
4, 8, 12, 16, 20.
et cetera, et cetera, et cetera. So, you know what? I misspelled. Not one of y'all noticed I misspelled multiples. Multiples. You're supposed to be taking a test back there.
Well, I'm just trying to. I don't
multiples.
I don't look at what you're writing. I just listen. I just listen to what you're saying and I write it.
I wrote multiples.
Multiples.
I wrote multiples.
Multiples.
It looks like dot in between the T and the E.
Kelly, concentrate back there. All right, example of okay. So look, examples of multiples. So Tanner, do you see what multiples are?
Yes, ma'am.
Are they getting bigger or smaller?
They are getting bigger.
Okay, so if I were to say what are the multiples of 10, and you tell me 2, 5, would that be correct?
No.
No, because what we're doing here, it's like 4 times 1, 4 times 2, 4 times 3. Do y'all understand what this is?
Yes.
Okay, and then 4 times 5. Okay, now examples, of factors. Examples of factors. For example, let's do 10. What numbers can go into 10? Natalia, give me one.
1.
Very good. Tanner, give me another.
2.
2. Joseph, give me another.
3.
3 can go into 10 evenly?
Oh no.
And remember, it's, 5. And look, okay, so actually, Joseph, I'm glad you said that. So Tanner, he said 3. Can 3 go into 10 evenly? Look right here. No remainder. So what they really mean is evenly. Hold on. And then what's the last one?
10.
10.
Times what? Class is already up.
Yeah, but remember you come in after lunch.
That's right, we had chapel this morning.
Okay, any questions?